A special type of motion is called uniform motion. Oh, sorry, uniform acceleration. All right, a special type of motion is called uniform acceleration. All right. In uniform acceleration, that means acceleration is constant. There are 4 equations that you can use. The 4 equations are Vuat, Suat, and Vuas, also which I call Suave. You can also use this formula, VAV equals S on T equals U plus V on 2. Alrighty, those are the formulas for uniform acceleration. All right, those are the formulas for uniform acceleration. All right, great. We are unlikely to be using this one today. I really don't think we'll be using this one today. So today, we're literally doing the exact same thing. The difference is that today we're talking about up and down in the Earth's gravitational field. So for today, A is negative G. Alrighty, and when I say negative G, I mean negative 9.8. The value of acceleration on Earth is negative 9.8. So for today, anything going up is positive. Anything going down is negative. We're going to stick with that convention. If something's going up, it's positive. If something's going down, it is negative. Alrighty, that's it. Okay, that's literally all the theory to today. So today is exactly the same as last week. All right, today is exactly the same as last week. The only difference being that we will be using A is negative G. All right, that's the only difference. All right. All right, you got to read the question. It tells us the acceleration is negative 9.8. It tells us it leaves the hand with a velocity of 25 meters per second, so use 25. U is not 0. I agree. The ball starts off stationary in your hand. But very, very quickly, while it's still in contact with your hand, it lifts off. All right. So U is 25 meters per second. All right. And what happens at the top? The velocity is 0. That's why it's at the top, because it stopped moving. All right. So I have U, A, and V. And it says how long will it take to reach the top of its flight? So I just want T. Which equations have A, U, V, and T? Vuat. V equals U plus AT. V is 0. U is 25. A is minus 9.8 times T. Can I get a T? You just bring 9.8 across, then you're literally solving 25 equals 9.8 T. T is 25 divided by 9.8, which is 2.55 seconds. And that is how long it will take. That's it. It's still just comprehension. Question 2. A ball falls from a rooftop tennis court. The tennis court is 150 meters above the street. Okay, so some ball is falling down. The ball has no initial velocity. How long will the ball take to hit the street? What letters do you have? All right, I guess I've got acceleration is negative 9.8 because it's on Earth. What else do I have? I have the initial speed. It was 0. What other letter do I have? S. I agree. The tennis court's 150 meters below. So what's S? Negative 150. Hopefully no one's writing positive. The ball is not going up. The ball is going down. The displacement is not positive 150. It is negative 150. All right. It is negative 150. All right. And what does the question want? How long does the ball take to hit the ground? Okay. It sounds like they just want T. They also want, what would the vertical velocity of the ball be just before it hits the ground? That sounds like a final velocity. All right, so which formula has got A, U, S, and T? S equals UT plus half AT squared. S equals UT plus half AT squared. S is negative 150. U is 0 plus half times negative 9.8 times T squared. So then really bring the negative 9, half times negative 9.8 is 4.9. Bring the 4.9 to the other side. So t is square root of 150 divided 4.9. So how long did it take? $5.53 Perfect. That's how long the ball took. All right. All right. They also want to know what's the velocity of the ball just before it hits the ground. Now, I know the velocity when it hits the ground is 0, but when it just hits the ground, it's not 0. Yes, if you jump off a building, you don't need to be like, oh, it's okay, my final velocity is 0. No, the final velocity is going to be 0 when you're no longer you. All right, when you hit the ground, you're not going to hit with a velocity of 0. Yes, it will become 0 when you probably are no you anymore. Alrighty, so I don't want anyone thinking the final velocity when someone jumps off a building is 0. All right, not straight away. All right, so which letter will help me find out V? I'm so spoiled for choice. Honestly, I'll just use the easiest formula, V equals U plus AT. All right, I just picked the easiest looking formula. The easiest looking formula was V equals U plus AT. U was, what was U? What was U? U was 5. No, it was 0. A was negative 9.8, and I just worked out time was 5.53. So what do we get a V of? Negative? Negative 54.2. 3 significant figures. I'm not surprised that it's a negative number. It should have been a negative number because it's going downwards. So the answer is, what would be the vertical velocity? The answer is 54.2 meters per second downwards. All right, 54.2 meters per second downwards. Excellent. Next one. It's just what we did last week, except acceleration is negative 9.8. Question 3. A helicopter delivering food supplies to a flood-stricken farm hovers 100 meters above the ground. A package is dropped from rest just outside the door of the helicopter. Calculate how long the package takes to reach the ground. Well, that just sounds like the question that we just did. That sounds exactly like the question that we just did. What are the letters? Initial speed, 0. That's one of the letters. Another letter is final speed. We don't know. Acceleration, negative 9.8 because it's on Earth. All right. What other letters do I have? Use that. S, it falls 100 meters, negative 100. And again, the question wants T, and again, the question wants V. So it's again the exact same stuff. Nothing different from the previous question. Nothing different from the previous question. Exact same letters, and it wants the exact same things. This is comprehension. All right, this is better than chem. You don't have to memorize anything. All righty, so S this time is negative 100. So T is 100 divided 4.9, and then what's the time taken? Anybody? Time taken? .52 seconds. Perfect. All right, and then keep that answer exact. Ideally, guys, keep it exact in your calculator. Learn to store values in your calculator because now I need to do V equals U plus AT. So what's 4.52 times, what's your answer times 9.8? Perfect, so 44.3. Negative 44.3, so the answer is it hits the ground at 44.3 meters per second, ignoring air resistance. That's it. Alrighty, that's it, comprehension. All right, I just did comprehension. Alrighty, next one. Alrighty. A ball is hit vertically upwards at 12 meters per second. Alrighty. How long will it be before the ball is moving at 2 meters per second? Nice question. All right, a ball is hit vertically. Give me some letters, guys. We're assuming on Earth, so I'm going to say acceleration is negative 9.8. What other letters do I have? Other letters? Come on, guys, find me some letters. Yes, the initial is 12, positive 12, because it's going up. What else? The final is 2. and we want t. Which formula has got u, a, v, and t? What? V equals u plus at. Simple as that. So we do v equals u plus at. V is 2, u is 12, a is dunno. Sorry, I do know, sorry. 9.8, t is dunno. 2 take 12 is minus 10. Minus 10 divided by minus 9.8 will give us t. So how much is that? 1.02 seconds. That is how long it takes. Very few students I know get that question fully correct. Because the question said the ball is thrown upwards. How long will it be before the ball is moving at 2 meters per second? Guys, if you throw the ball upwards, isn't it going to be moving down at some point in time as well? So there's going to be some point in time where it's moving up at 2 meters per second. And at that exact same time on the way down, it's going to be moving down at 2 meters per second. So there's going to be the time taken to get to this point, and then a little bit later, it will be going at 2 meters per second on the way down. So it's actually a second answer. To get the second answer, you have to consider the fact that v is not just 2, v is plus or minus 2. There is a time when the ball will be moving at 2 meters per second down. So you do the exact same working out, except you have minus 2 as your final velocity. So very few kids see that straight away. All right, and if you do see it straight away, you bring it across, minus 2, bring the 12 across, so that's minus 14. All right, what's that now? It should be a bit more time. 1 point? Almost 1.5. 1.43 seconds. So there are 2 times it takes for the ball. 1.02 seconds on the way up and 1.43 seconds on the way down. Nice. All righty, question number 5. Question number 5. On winning a tennis match, the victorious player, Michael, smashed the ball in the air at 30 meters per second. What's the maximum height reached by the ball? All right, can you just tell me all the letters? What's the letters for on the way up at least? For on the way up, what are the letters? Acceleration, negative 9.8. Acceleration is negative 9.8. What else? Oh, sorry, you're right. Thanks, guys. It says take gravity as 10. So if it says that, just make it 10. It makes the math easier as well. Acceleration minus 10 because the question says so. What else? Initial velocity of the ball, 30. All right. We want the maximum height reached by the ball. What does the ball do when it's at its max height? It stops. So velocity 0 meters per second. If a ball is at its maximum height, it stops. All right. Cool. And I want the maximum height reached. The one S. Which formula has got U, S, A, and V? Suave. V squared equals U squared plus 2AS. V is 0. U is 30. A is negative 10. S, I'm trying to figure out. I think S is 4.50. No, 450. 45. What is it? 45? Yep. 45.0 to get full marks. That is the maximum height reached by the ball. How long does the ball take to return to its starting point? Well, here's the thing, guys. If I can figure out how long it takes to get to the top, then to get back to the starting point, I just have to double that time. Because it's symmetrical. Go up and then come back down the exact same amount. If you're going to come back down the exact same amount, the time taken should be the exact same. So then what will I do? I'll just figure out the t. I'll say t is missing as well. All right, I'll also say t is missing. So I'm spoiled for choice. What equation do I want to use? I guess I'll use, I feel like v equals u plus at. V is 0. U is 30. A is minus 10. T is what I'm trying to figure out. Turns out T is 3. The time taken to go up is 3. So what's the time taken to go up and down? 6. But you have to write 6.00 to get the marks. It took 6.00 seconds to come back down to where it was. So it took 3 seconds to come up and 3 seconds to come back down. So it took 6 seconds total. Part C says calculate the velocity of the ball 5 seconds after Michael hits it. That means it's on the way down. I expect to get some negative answer. I expect the answer to be some negative some number because it must be on the way down because it took 3 seconds to go up. So change of letters a little bit. Change of letters a little bit. So A is still negative 10. A is still negative 10. U is still 30. V is now unknown. And what we actually know is time is 5. They want to know what happens after 5 seconds. So time is 5. V is, again, don't know. That's what I want. So I again use V equals U plus AT. V I don't actually know this time. U is 30. A is negative 10. Time is 5. I'm getting negative 20. So the answer is therefore 20.0 meters per second down. Velocity is a vector, so you must give a direction. B. What is the acceleration of the ball at its maximum height? When it's at the top, guys, at the topmost point for a split second, what's its acceleration? All right, I was just trying to bait kids into saying 0. Gravity doesn't turn off for a little bit. So the answer is still negative 9.8. The answer is still, or in this case, I guess 10. So the acceleration is always negative g. Think about it. Gravity doesn't stop for a little bit. All right, gravity is always acting on it. There always is a negative 9.8 acceleration. The velocity is 0 at the top, but the acceleration is never 0. So the answer is negative 10, which means therefore 10 meters per sec, 10.0 meters per second squared downwards. Draw an acceleration versus time graph. Oscar, what will my graph look like? What will my acceleration versus time graph look like? A straight horizontal line at negative 10. I agree. This is what the acceleration. And if you want to be really, really good, you'll just like make a little remark here that's 6 seconds only. Then it stops. All right, this is the acceleration in ms to the negative 2, and that's what it looks like. They also want a graph of velocity versus time. They also want a graph of velocity versus time. So if they want a graph of velocity versus time, it'll look like this. All right. They want a graph of velocity in meters per second versus time. So if I think about it, if I do think about it, the ball was going up initially. The ball was going up initially. So, and then it started off at a speed of 30 meters per second. The ball did start off with a speed of 30 meters per second. Then it got higher and higher and higher, meaning it got slower and slower and slower. And at the 3 second mark, it actually stopped for a while, for a split second. And then at the 6 second mark, it like was going at negative 30. At the 6 second mark, it had actually reached a velocity of negative 30. All right, that's how it works. So it took 3 seconds to get to the top, and then another 3 seconds to like get there. And at that second point, it was obviously going at negative 30 meters per second. That is a graph of its velocity versus time. Anyone got any questions about that? That's a nice, likely question to come up, graphing some velocities versus time versus acceleration versus time. That's it. All right. Cool. All right. Don't worry too much about 6 questions. I'm just going to move on to question 8. So let's move on to question number 8. Okay, the next two are pretty straightforward. A pole vaulter just clears a pole of height 5.25 meters and falls onto the mat. All right, I'm going to draw a picture of what he's doing actually. So what he's doing is the pole vaulter goes up. The pole vaulter goes up and he comes back down onto a mat, which is 0.75 meters of the ground. The mat's right here, 0.75 meters off the ground. 0.75 meters. That's what the pole vaulter does. He clears a pole of height 5.25 meters. Okay, fine. So 5.25. That's 5.25. I hope everyone realizes the time taken to do this is not the same as the time taken to do that because they're not equal. All right, it's not symmetrical fully. Okay. Anyway, with what velocity does he hit the mat? Tell me what letters you have. What letters do we have? All right, he's probably doing it on Earth. So acceleration is negative 9.8. What else do we have? We have pole vault just clears, blah, blah, blah. Some people saying you have initial velocity. I don't think so. Where does it tell you what speed he launches at? Some people will say, oh, isn't his initial velocity 0? If he jumps up with an initial velocity of 0, he's not really jumping up. Then he's just there. All right. I guess I have a, ooh, just clears. Just clears it. If he just clears it, does that mean he was at his max height? And what does happen at max height? Velocity is 0. That's why he just clears it. So you have to like read a little bit. All right, if he just clears it, his velocity is 0. So I'll write that down. Velocity is 0 meters. Final velocity is 0. And what's his displacement? Well, which part of the journey am I looking at? Now, I need to decide which part of the journey I'm looking at. Alrighty. Guys, I want the speed with which he hits the mat. I realized that really, I don't care about this part of the journey. This part of the journey doesn't tell me the speed with which he hits the mat. Do you know which part of the journey does tell me which speed he hits the mat? This part of the journey. I'm actually interested in that part of the journey. I'm actually interested in this part of the journey. I don't care what happens on the way up, to be honest. I care about what happens on the way down because the question's asking with what speed did he hit the mat? Some people might say that, can we use the whole thing? If you use the whole thing, I can't use the fact that the speed here is 0. I really want to use the fact that the speed at the top is 0. If I want to use the fact that the speed at the top is 0, I can't use this as the journey because otherwise I would need the velocity right here. So turns out that it's not v that's 0. If this is the part of the journey that I'm looking at and is obviously on the way down, what's actually 0? U is 0. His initial velocity is 0. Think about it. He just clears the mat, meaning he stopped for a second. Not mat, the pole vault, and then he's on his way down. Anyone trying to do the whole journey, you'll struggle. Because if you're doing the whole journey, you only have 2 letters. You have the acceleration and you have the displacement. That's it. You only have 2 letters. If you want to do equations of motion, you need at least 3 letters to use the Suvat equations. So, all right. Anything else I have? I guess I do have S, guys. That's 5.25. That's 0.75. So how much is this? All right. 5.25. Take 0.75. All righty. And what's that? 4.5. Up or down though? down. Now, someone's asking me a very good question. Someone's asking me, Kunj, shouldn't the acceleration be positive? Alrighty. The way that I do questions, anything going up is always positive. Anything going down is always negative. And which way does gravity always point? Down. So for that reason, my acceleration will always be negative 9.8. Now, if you're very, very good, you can actually make down positive. But then you've got to change everything to that. And I think it's just a bit hard. So my acceleration is still negative 9.8 because gravity is still pointing down. Alrighty. I've got A, I've got U, I've got S. Which letter do I want? Which letter do I want? I want T. Which formula has got U, S, A, and T? Sorry. I want V. Thank you. I want V, not T. I want V. Which formula has got U, A, S, and V? V squared equals U squared plus 2AS. Cool. Suave. Agreed. All right. Can I get what V squared is before you square root it? I would like V squared before you square root it. How much is it? 88.2. Positive though, right? Because it's 2 times negative 9.8 times negative 4.5 because it's on the way down. I hope everyone agrees S is negative. All right. Now what? Shh. All right, pop the food away. I'm sure you can last the lesson. All right, I'm sure you can manage. All righty. All right, so what does that mean? V is. Now, be very careful. When you square root something, it's plus or minus. You need to remember that when you square root something, it is always plus or minus. All righty. So what is plus or minus square root of 88.2? Well, what is square root of 88.2? How much? 9.39. Can I have one more decimal just because actually, you know, I'll keep it. Plus or minus 9.39. And which one do we actually want, guys? When he hits the mat, is he up or is he down? Is he going up or is he going down when he hits the mat? Going down. So we actually pick the negative root. You must actually pick the negative root. The question, so the answer is therefore 9.39 meters per second downwards. It is very important that when you square root, you do plus or minus. In this case, we actually use the negative one because it was on the way down. That is his velocity. All right. So you had to realize we're using this part of the journey. All right, next. Shh. If the mat compresses to a maximum thickness of 0.05 meters when the athlete hits it, all right. What is the mat's acceleration as he hits the mat and slows? All righty. So guys, we're talking about what the guy does, the mat now. We're talking about what the mat does. We're not talking about the guy anymore. We're talking about the mat. The mat compresses to a minimum thickness of 0.05 when the athlete hits it. What's the mat's acceleration as he hits the mat and slows down? All right. Little bit trickier. With what speed does he hit the mat? With what speed does he hit the mat? You just worked it out. 9.39. He hits the mat at a speed of 9.39. Now, guys, if he's in contact with the mat, is acceleration negative 9.8? No, acceleration is only negative 9.8 if you're in the air. Well, technically in the vacuum. Alrighty, as soon as it's touching the mat, I don't want anyone telling me acceleration is negative 9.8. I'm sure everyone agreed that if you are lying on a mat, nobody ever says, oh, look at me accelerate at 9.8 through this mat. All right, if you're lying on a mat, your acceleration would not be that much. So then I'm just going to do what I did last week, just normal equation of motion, no acceleration is negative 9.8. So guys, with what speed does he hit the mat? 9.39. So my initial speed is 9.39. Now some kids might tell me, Kun, shouldn't you do negative because he's going down? Yes, he's going down, but remember, this is not really gravity anymore. So this is just like what we did last week. So I'm just pretending down is positive because it's not really gravity. So his initial velocity is 9.39. Obviously, what's the final velocity if the mat stops moving? 0. Alrighty. And guys, I've made a bit of a mistake. This is not the mat's acceleration. This is what is the athlete's, the vaulter's acceleration. It should really say what is the vaulter's acceleration. Think about it. The mat's, I mean, I guess the mat is kind of accelerating, but this is really the vaulter's acceleration. What is the pole vaulter's? What is his acceleration as he hits the mat and slows down? That's what it really is. What is his? Cool. So U is this, V is this. What else do we have? We have the distance that he moves through the mat. He moves 0.05 meters. And we want to work out acceleration. I expect it to be negative because he's obviously decelerating when he hits the mat. It would be a very weird mat if he doesn't decelerate. Again, V squared equals U squared plus 2AS. I personally use V and U. Some of your schools might write VI, VF, or V1, V2, which I find a bit annoying. Alrighty. Most schools allow you to write V and U. Acceleration, I don't know, and S is 0.05. Who's got A for me? Should be negative something.
Compresses to a minimum thickness of 0.05. Doesn't that mean it moves 0.7?
You're completely all right? Guys, if the mat compresses to this thickness of 0.05, meaning the mat gets really, really skinny, you're completely right. What does he actually move? He actually moves 70 centimeters. Everyone agreed? So you're completely correct. So actually, S is 0.70 meters. Thank you. All right. That's a good, I've been doing this question for like 10 years and no one's ever said that. All righty. Makes up for your rowdy behavior before. All righty. So what do we get? A is negative 63.0 meters per second. Basically, it means what is his acceleration? Therefore, 63.0. Which way is he accelerating? Down or up? Is he accelerating down or up? Up. Good. Anyone saying down? That's not good. Imagine you hit the mat and then you keep accelerating down. It's not looking good for you. All right. When you hit the mat, I'd hope to be accelerating up. And people need to remember that accelerating up doesn't mean moving up. Accelerating up just means the velocity is changing in the upwards direction. Excellent. All righty. Question number 9. 2 physics students conduct the following experiment from a very high bridge. Raymond drops a 1.5 kilogram shot put from a vertical height of 60 meters, while at exactly the same time Ryan throws a 100-gram mass. Guys, do any of our equations have m in them? Any of the equations I taught you have m in them? No, it was called SUVAT. It wasn't called SUVMAT. It was SUVAT. There was no m. That means all of this motion is independent of mass. If you ignore air resistance, mass is irrelevant. So, that makes it easy knowing that. So 2 physics students, blah, blah, blah. Raymond drops a 1.5 from a height of 60 meters, while exactly at the same time Ryan throws 100 with an initial. Okay. Are these free-falling objects or are they not free-falling objects? Yes, they're in the air. If they're in the air, they're free-falling objects. Then back to like down being negative and up being positive. Down to like back to acceleration being negative 9.8. So what letters do I have? The letters that I have is this. Let's do the shot put first. What do you guys know about the shot put? What do we know about the shot put? Shot put, I know that I know that it's dropped, right? So initial velocity is 0 for the shot put. It's dropped on Earth. And if it's dropped on Earth, acceleration is negative 9.8. Initial velocity is 0. And it fell 60 meters. So S is negative 60 because it's on the way down. And we want T. Which formula has got A, U, S, and T? S equals U, T plus half AT squared. So we're going to use SUAT. If you have U, S, A, and T, we use SUAT. S is negative 60, U is 0, so that's 0 plus half times negative 9.8 times T squared. Who's got a T for me? What's 60 divided 4.9 square rooted? What is T? Five, 0 seconds. Perfect. How long does the 100-gram mass take? Well, what's the difference with the 100-gram mass? It still has an acceleration of negative 9.8 still, but it's thrown downwards. He literally throws it down with an initial velocity of 10 meters per second downwards. So U is negative 10. And the distance, well, he doesn't throw it from the same spot. He throws it from a point 10 meters above Raymond. So it actually falls 70 meters. So S is negative 70. And we want T. All right. Which formula has S, U, A, and T? Yes, I agree. S equals UT plus half AT squared. Now stop and think what we did last lesson. Stop and think what you did last lesson. If you don't think about what you did last lesson, keep going and see what happens. Alrighty. If you do stop and think about what we did last lesson, you'll specifically remember that if you're going to use S equals UT plus half AT squared to find T, and U does not equal 0, if you continue doing it, what will you get? A quadratic. What's better than having to do a quadratic? Find V first using V squared equals U squared plus 2AS. Then find T using V equals U plus AT. There was a reason we discussed that last lesson. All right, there was an explicit reason to want to discuss that last lesson. I don't want to have to use a quadratic formula. I really don't. Alrighty, so anyone using S equals UT plus half AT squared, either you're going to use a quadratic formula or you're going to do V squared equals U squared plus 2AS first. V, don't know. U, neg 10. A, negative 9.8. S, negative 70. Can I get what V squared is, guys? Before you square root it, can I just get V squared? One, 472. All right, we must do plus or minus. What is square root of 1472? 38.4. Is V final velocity? Is that thing going up or the thing going down? Is it going up? Is the ball going up or the ball going down at that point? Down. So hopefully everyone's giving me the negative root. If you gave me the positive root, you'll actually get it wrong. It is actually going at negative 38.4 meters per second because it's on the way down. Alrighty. All right, and then I said use V equals U plus AT. If anyone used the wrong V, you'll probably get a negative time. And that wouldn't make any sense. Or you'll get the wrong time. Sometimes you get a positive time, but it's still not the correct one. Negative 38.4 equals. Can I just have one more decimal? 38.37. All right, just because it's carrying on to the next line of working. Negative 38.37 equals u, which I know is negative 10 plus acceleration, which is negative 9.8 times t. Do your algebra correctly. When you bring minus 10 across, it becomes plus 10. So then the minus crosses out. What's 28.37 divided 9.8? 2.9 something, I think. 89. That is how long it takes. That's so much better than having to use the quadratic formula. All right, by the way, if you did use the quadratic formula, how many answers would you have got? 2 answers. That makes sense because there's a plus root 1472 and then there's a minus. All right, if you use the wrong one, if you use plus, you'll get the other time which the quadratic formula would have given you. So you got to really think about what V stands for. And if V stands for final velocity, then you better use the negative version. So T is 2.89 seconds. Cool. Do your maths correct. When you bring a minus 10 across, it became plus 10. All right, next one. At what time will the 100-gram mass overtake the shot put? At what time will the 100-gram mass overtake the shot put? All right, who's got a bit of a head start? Who has to travel more? I'm pretty sure the mass has to travel more, right? Because the mass is from higher up. How much more does the mass have to travel? 10 more meters? So look at my working out that if one person overtakes the other, it means the distance traveled by the mass is equal to the distance traveled by the shot put plus 100. Oh, sorry, plus 10. Plus 10. The mass travels exactly the same as the shot put plus an extra 10 meters. All right. So, okay. So the mass. Okay, so distance traveled by the mass is ut plus half at squared. The distance traveled by the shot put is also ut plus half at squared plus 10. Just make sure you use the correct masses, correct u. So what was the mass's original speed? 10. So this becomes 10t plus half times minus 9.8 times t squared. This here is 0. I hope everyone realizes for this one, ut is 0. The shot put's initial velocity was 0. So this bit just becomes 0. So we don't even worry about that. 0t plus half at squared plus 10. Alrighty. So what does this become? 10t, take 4.9 t squared equals, I forgot to write a as negative 9.8. So half times negative 9.8 times t squared. So then this becomes also minus 4.9 t squared plus 10. The minus 4.9 t squared minus 4.9 t squared just crosses out. So solving 10t equals 10, which gives us t equals 1. There you go. After 1 second, it catches up. These are getting harder. Yeah, now they're getting a little bit harder. After 1 second, it catches up because catch up means they both have covered the same distance. All righty. All right. Question number 10. All right. Can everyone put question 10 in their notes page? 10 should go in your notes page. I've already said it once, but I'm really going to make it very clear. All right. I'm going to make it explicit. I'm going to make my instructions very explicit. All right. A stone is thrown vertically 14 meters per second upwards from a bridge. How long will it take to reach the water, which is 14 meters below? Oh, sorry, 21 meters below. So the water is 21 meters below. That means this distance here till the water is 21 meters. How long will the stone take to reach the water? Alrighty, there are 3 ways to do this question. I have a preferred way, but there are 3 ways to do the question. I'm going to show you all 3 ways. I want to know how long it will take to reach the water. This goes in your notes because this comes every year. Without fail, this question comes up. All right, I think the next few questions are just like that. See, another one like this. Another one, some archer firing it. Okay, the next few questions are all just like this. So that's why you're putting it in notes. All right, there are some kids that break it up into 2 sections. It takes longer to do it this way, but it still gives the correct answer. And guys, don't be silly and tell me what about the time taken to do this. It's technically just going up and down. I'm just doing this so that the picture doesn't overlap so you can see it clearly. Alrighty, so we're going to worry about this and we're going to worry about that. All right, Adi, I'm going to work out the time taken to do this. I'm going to work out the time taken to do that. Then I'm going to add the 2 times together. That is one way to do the questions. Help me out, Adi. What do you know about the red part of the journey? When it throws the stone up. Initials 14, yep, and he's doing it on Earth, so acceleration is negative 9.8. Acceleration is negative 9.8. Initial is 14. Keep going. Final velocity at the top is 0. Yes, you are right. It stops moving at the top. And I want to work out what T is. I'll call it T1. Happy for me to call it T1? Alrighty. Which formula has got all those in it? Vuat? V equals U plus AT. V is 0. U is 14. A is minus 9.8. T1, don't know. Can someone tell me what T1? T1 is 14 divided 9.8 because the 2 negatives cross out. What's 14 divided 9.8? I'll take 3 decimals, please. 429. Thank you. T1 is 1.429 seconds. That is how long that took. All right, can you tell me letters for the yellow part of the journey? Initial velocity 0, yep, and A is negative 9.8 because we're still on Earth, so now we're doing the second part of the journey. What else? V is 0, so when the rock hits the water, it stops, it hits it with no speed. Might as well just jump off the building because no worries, my final speed should be 0. So I agreed, V is not 0. I'm sure it hits it. All right, what other letter? And I'm glad you're not telling me S is 21 because it's clearly not, because 21 is only this much. Do we have any other letter? But then there's going to be 2 unknowns. If I call this, okay, I'm glad he said that. He said, Kunj, can you call this X? How about I go back to the red and figure out what the distance is? Oh yeah, that's a better idea. Everyone agreed? We can go back to the red part and figure out what that S is. Alrighty, so I'll call it S. Or S1, whatever. Alright, it's just S1 that should do the job. So guys, let's find out the S for the red part of the journey. Let's find out the S for the red part of the journey. So I guess I'll do S equals UT plus half AT squared. Or I'll do, if you really want to, you can do V squared equals U squared plus 2AS, because that way it doesn't use the T from before. So there's no rounding error. This way there'll be no rounding error at all. So V was 0. 0 squared equals U was 14 squared plus 2 times minus 9.8 times S. Can I get an S, please? Can I please get an S? What's 14 squared? Divide 19.6. What's 196 divide 19.6? Is it 10? Someone correct me if I'm wrong, but I feel it's 10. It is. All right. 10 meters. All righty. So that distance there is 10. All right. Cool. That distance there is 10. Now what? Now what, guys? Now that I know the distance is 10, I feel pretty good. I feel really, really good. So, Adi, if that's 10, we just worked out that this is 10. So what's the S? 31. It's going up even more. It's going 31 meters up. Negative 31. All right, I agree. S is negative 31. So guys, now for the orange section, I can say S is negative 31 meters. And now I can figure out T using S equals UT plus half AT squared. And the good thing about using S equals UT plus half AT squared here is the T is not the U is 0. So it's not going to be a quadratic. Negative 31 is 0 plus half times minus 9.8 times T squared. Who's got the value of T? It's the square root of 31 on 4.9. Who's got the time taken to come back down? I expect it to be more than 1.429 because it's bigger journey than before. 2.545, which 515, which means how long did the entire journey take, guys? The entire journey took 1.429 seconds on the way up and 2.515 seconds on the way down, and the time is 3.944 seconds. Who likes that way of doing it? All right, not many. Just took forever. But I had to break it in the middle, and it wasn't even as simple as times by 2. You can do times by 2 if the way up is the same as the way down, but this one wasn't. All right, for this one, the way up was not the same as the way down, so then that's how I did it. All righty, cool. All right, let's do it the other ways. Let's do it using technique 2 or 3. Technique 2 or 3 treats it as one thing. We do it in one shot. Adi, go for it. Tell me all the letters about doing it in one shot. Yes, the acceleration is neg 9.8. I agree. Initials 14. Yep. Displacement doesn't care about what happens here. Displacement's not distance. Displacement's start to finish. It is negative 21. Start to finish, negative 21. It couldn't care less what you did in the middle. All right. And I want T. And I did say there's 2 techniques, right? All right. One's for those people that prefer to use quadratic formula and those that want to do S equals UT plus half AT squared. This is for people that want to do S equals UT plus half AT squared and do a quadratic. I'm sure people remember correctly that if you're using S equals UT plus half AT squared and U is not 0, you are going to get stuck with a quadratic. And then I wrote sad face. Plus half. A is negative 9.8. T, I don't know. That's a shitty quadratic. Bring everything to one side. 4.9 T squared. Take 14T. Take 21 is 0. Now use quadratic formula. T is minus B plus or minus square root of B squared. Take 4AC. What a load of not nice. Alrighty. Alrighty. Cool. And then divide by 2 times 4.9. That took forever. Go for it. Put in your calculator. What is that? That's technique number 2. Not nice.
Negative 1.09.
Negative 1.09. 3.95. 94, 95, and whatever, close enough. We kind of got 3.95 before. Oh, these were pretty exact values. I wonder why the rounding went funny. But anyway, cool. That's one way. Bit of effort, needed to use quadratic formula. Okay, what's the other way? What was the instructions that I gave you? Alrighty. What's the instructions I gave you? Don't find T first. Find what first? V. And how do you find V? By using which formula? V squared equals U squared plus 2AS. V is, don't know. U is 14 plus 2 times minus 9.8 times S is minus 21. When you square root it, what is it before you square root it? What is it before square rooting? 607.6. When you square root, I hope everyone's only giving me the negative root because I only want to know on the way down. I only want to know on the way down. And what is your V? Negative 24.65. And now there's nothing stopping me from just doing V equals U plus AT. Negative 24.65 equals U, which is 14 plus minus 9.8t. Bring the 14 across. So that would be minus 38.65. Divide by minus 9.8. And hopefully, what do you get T is this time? Hopefully everyone's telling me 3.95 again. I hope. 94. All right. Odd that Paula, we got a 3.95. Did you put it in exactly like that? All right, anyway, I'll just pretend it's a 4. All right, maybe one. Okay, anyway, are we all happy with that? Which technique looked the best? Number 1? Oh, 1, 2, or 3? I think 3 looked the best. Now, whoever says this is better, but yeah, I don't want to do that in the test, to be honest. Unless you guys have bought the scientific calculator that does the quadratic formula. All right, there is a scientific calculator that does quadratic formula for you. But that doesn't really help because you still got to write this to get the mark. Not really that special. Great. That is important. Everyone got that? And Paula, we'll always get a negative answer. 1 negative, 1 positive. All right. Now it's important that you guys understand this. Shh. All right. Guys, if a projectile is here and the displacement's negative 21, either it does this or it goes back in time and does that. And obviously you can't go back in time. But what if a projectile's doing this? Now look here clearly. What if I want to know how long it took to get to here? All right, guys, is this displacement to get to here the same as the displacement to get to there? And are they both going to take positive time or negative time? Both will be positive time. What I'm trying to tell you is the quadratic formula may give you 2 times. One is the time taken to get to that particular spot on the way up. And one is the time taken to get to that spot on the way back down. So what I'm trying to tell you, both times are not necessarily negative. All right, sometimes you actually get 2 positive times. One's the time taken to get up to that point, another one, time taken to coming back down. The only problem is that if you start here, then to be 21 meters below, you either have to go forward in time or you have to go backwards in time. So all I'm trying to tell you, you will not necessarily get 1 negative, 1 positive. It is very possible you get 2 positive answers. Got it? It's possible you get 2 positive answers. Any question that looks like this, you'll get 1 positive. Maybe I'll write this down for you. How do I write this? What do you want to write for them, Kunj? I want to write this for you. All right. If you have something like this, this is your notes that I guess you can write. If you have something that looks like this, and if you're going to do S equals UT plus half AT squared, and you're going to use the quadratic formula, the times you're going to get is 1 positive number, 1 negative. Oh, you'll get a negative number and a positive number if you do decide to use the quadratic formula. However, if your question looks like this and you end up, that's the same. If your question looks like this and you end up slightly higher and you use S equals UT plus half AT squared, and you again use a quadratic formula, what will you actually get? You will actually get 2 positive times. You'll get a positive time and another positive time. All right. For this one, you'll only get 1. This will be your, yeah, because think about it. To get to here, it takes a positive amount of time. To come back here, it also takes a positive amount of time. For this question, to get to here, it takes a positive amount of time. To get to here, that means going back in time. Alrighty, so that's my notes. And if I just confused you, pretend nothing just happened. If I just confused you with all of that, pretend nothing happened and just don't do S equals UT plus half AT squared. Just use my instructions from before. Excellent. Next question. Alrighty. Shh. A stone thrown from the top of the building. Blah, 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 blah. Determine the time at which the stone reaches its maximum height. That means, class, we're only looking at this part of the journey. We're only looking at that part of the journey if you want the time for the stone to reach max height. What letters do we have about that part of the journey? I've got a U. Is 20. He throws it up at 20 meters per second. The question says so. In fact, the letters here also say so. U is 20. He's doing it on Earth. So acceleration is negative 9.8. He's doing it on Earth. So acceleration is negative 9.8. We have a velocity. What would be the velocity at the top of its flight? 0. And the question wants a time taken. In fact, I read ahead and part B says find the max height of the stone. So then I need to work out a displacement as well. I need to work out both because I read ahead. So first I'll do V equals U plus AT. V is 0, U is 20, A is minus 9.8, and T is T. Who's got T? What's 20 divided 9.8? .04 seconds. Part B wants the maximum height reached, so I need an S. I don't want to do S equals UT plus half AT squared because it uses the old value. I'd rather do V squared equals U squared plus 2AS, but up to you. V 0, U 20, A neg 9.8, S don't know. Who's got an S for me? It's whatever 400 divided by 19.6 is. All right. Acceleration is never positive. All right. Someone's asking me, would the acceleration be positive because we are going up? No. The velocity is positive because we're going up, but the acceleration is never, ever positive. Gravity will never, ever go up because that would be weird. If you threw something up and it was accelerating up, it would just get faster. All right. So don't confuse acceleration with velocity. When things are going up, velocity is positive. Acceleration is always negative. All righty. So what's S? $12.4? $20.4. All righty. And then, yes, but the question doesn't want the displacement. The question wants the maximum height of the stone. So to get the maximum height, you got to add the 50 meters. So the maximum height of the stone is the original 50 meters plus the 20.4. So the answer is 70.4 meters is the maximum height. Very, very, very common question. Alrighty. Part C is ridiculously easy. Part C is ridiculously easy. Find the velocity of the stone when it returns to the height from which it was thrown. Guys, how fast is it going here? 20 meters per second. So does anyone want to tell you guess what the speed will be at the exact opposite on the way down? Also 20 meters per second. It would be completely symmetrical. So the velocity of stone when it returns to the height will be 20 meters per second, 20.0 meters per second down because it's completely symmetrical. All right. All right. I'm not too worried about D and E as bit boring bits. Okay, not too worried. Okay. They just want the velocity in position after 5 seconds. There's nothing more to it. Okay. All righty. Let's go. Number 12. These are all very, 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 very good questions. Shh. So, an archer on the wall of a castle fires an arrow straight up in the air at a speed of 55 meters per second. He's on the wall, so it actually goes down. This is 35 meters. You can see how similar this question is to what we did earlier. Alrighty. What maximum height does the arrow reach? Does everyone in the class agree that we only look at this part of the journey to begin with? We only look at that part of the journey, otherwise I can't work out the maximum height. I only look at that part of the journey. All right, Adi, what letters do I have about that part of the journey? Yep. Oh, U is 0. That would be weird, wouldn't it? If he can't expect his arrow to go up if he doesn't fire it up. That's better. U is 55. That would make sense. I'm sure you'll agree it would be weird for the arrow to go up if the initial velocity was 0. But everyone thinks 0 because they think, oh, it's not moving. Yeah, but it starts moving as soon as you let go of it from your bow. All right, what other letter? At the top of its flight. V is 0. I agree. And we want how long does it take? No, we want height. So we want S. What letters got all those in it? V squared equals U squared plus 2AS. V squared equals U squared plus 2AS. V is 0. U is 55. A is neg 9.8. S is S. Who's got an S for me? All right. Anyone got an S for me? Someone? What's 55 squared divided 19.6? 0.34. All right. So what's the maximum height that the arrow reaches? The maximum height that the arrow reaches is the 35-meter head start plus 154.34. And with scientific note, with 3 sig figs, 189 meters. That is the height reached. The next part says, how long does the arrow take to reach the ground? And with what speed does the arrow strike the ground? All right, Adi, do you feel like breaking up and you already figured out the time taken to actually, do you feel like taking out the time taken to do this and then finding out the time taken to do this and then adding them up? Do you feel like doing that? No. What do you feel like doing? Doing it together. All right. Cool. All right. So Isaac, all yours. Tell me all you know about the entire thing. Because we want to do it together. What do you know about the whole journey? You're still on Earth. A equals minus 9.8. What else? All right. Yes, Oscar. What else do we have? Yep. The initial velocity is still 55 meters per second upwards. What else? Yes, the displacement is still negative 35 because we still end up lower. Alrighty, displacement is neg 35. And what do we want? Time. Will you do S equals UT plus half AT squared? No. Why? Because you don't do a quadratic. What will you work out first? V. Doesn't that seem like a waste of time to figure out V first? No. What does part C want anyway? Oh, it wants V anyway, so I'm not even really wasting time. I'm just doing part C before I do part B effectively. Which equation to help us find out V? VUS. Yeah, so SWA. V squared equals U squared plus 2AS. V, don't know. U, 55. A, minus 9.8. S minus 35. Who's got a V for me? And what is it before you square root it? What is V squared? 371? 1? And then do we pick the negative root or the positive root? Is it on the way up or on the way down when it hits the ground? On the way down. So hopefully everyone's telling me the negative square root of 3711. How much is that? 60.9. Give me one more decimal, just 2. Alrighty. So then I do V equals U plus AT. I use minus 60.92. I use U is 55. I use A is minus 9.8. And that will give me the time in one shot. That is guaranteed to come up. I hope kids that have moved on from equations of motion at school did this. Otherwise, you really didn't do this. All right, you somehow skipped the topic with just the easy, fluffy questions. All right. What's the time for the whole thing? It's whatever minus 111.92 divided by 55 is. Oh, sorry, divided by minus 9.8 is. How much is that? 11-ish? Sorry, that should say minus 115, sorry. Is it minus 11-ish? Or 12? I don't know. 11.8 seconds. So the answer to that was 11.8 seconds, and we effectively, inadvertently, solved part C as well. The answer to part C was, what did the question say? With what speed does the arrow strike the ground? 60.9 meters per second. What direction? Direction? Down? No, wrong. It says speed. Don't give a direction. Don't give a direction if it says speed. All right. Otherwise, you'd be wrong. All righty. Are we getting the hang of it? All righty. The rest of the questions are pretty much the exact same. All right. So that is equations of motion. Next week, I start Newton's laws and forces. All right. That's what we do next lesson.